In this lesson, we are going to learn about the sine rule and how we can use it to find the missing sides and missing angles of a given triangle. Before we start using the rule to find missing sides and missing angles, can we understand about its basics? So, the rule states if we have A divided by the sine of A is just equivalent to B divided by the sine of B, which is also equivalent to C divided by the sine of C. But what is this A and B and C? A and B and C, the small ones, is just the sides of the triangle. Like in this case, this side is A, this side is B, and then this side is C. So, the capital A, B, and C are the angles directly opposite to these sides. So, for example, A is the angle directly opposite to side A, and I mean this angle here. Then, capital B is the angle directly opposite to B, and I mean this angle here. And then, capital C is the angle directly opposite to side C, and I mean this angle here. So, if we have A, then capital A is the angle directly opposite to the side here, then B, capital B is the angle directly opposite to B, and then C is the angle directly opposite to this C here. Then from there, we can use this rule here, which says if we have A divided by the sine of A, which is this angle, is just equivalent to B divided by the sine of B, which is this angle, which is equivalent to C divided by the sine of C, which is this angle here. We can use the logic of this rule, sine rule, to find any side of this triangle or any angle of this triangle. So, let's try with an example. So, in this question you are told, in triangle ABC, A is 8 centimeters, which of course means this here, the side. Then you are told B is 12 centimeters, meaning this side here. And then you are told angle A, which is this angle here, is 35 degrees. Then you are told to find angle B, which is this angle here. And then you are also told to find the length of C, which is of course the length of this line here. So the first thing we need to do is to look for what we are given. In this case, we are given A, B, and angle A. So we need to go back to the formula and see. We don't need to use the whole formula. We only need to pick what we are given and what we are asked. Like in this case, we are given A. We know it is 8 centimeters. So divided by the sine of A, because we have the angle of A, which is 35 degrees. Then we also given B, meaning we can say it's equivalent to B, which is 12 centimeters. Then divided by the sine of B, which is the one we are asked. So, up to that point, we can just stop the formula here. We don't need the last part because already we are just interested with the sine of B. And since we have A, we have sine of A, and we have the length of B, then we don't need the last part to get the sine of B. So now the formula reduces to A divided by the sine of A, which is equivalent to B divided by the sine of B. But you see, we already know the length of A, so now it becomes 8, which is the length of A, divided by the sine of A, which is the angle directly opposite to A, and it is 35 degrees, is equals to 12, which is the length of B, divided by sine of B, which is of course the sine of the angle directly opposite to B, this angle here. So now from there, we can just cross multiply, and we do have and becoming 8 sine of B, because I just took this sine of B, I cross multiplied here, it became 8 multiplied by the sine of B is equals to 12, this 12 multiplied by the sine of 35 degrees. Then from there, since I want the sine of b, then I can just say it is sine of b is equivalent to 12 sine of 35 divided by 8, and just divided by 8 on both sides so that I can eliminate the 8 here. So the sine of b, we can just get it directly from the calculator. We have 12 sine of 35 divided by 8. So if I go to the calculator and direct, you can just start with the sine of 35 degrees like that, which is, of course, let me write first the sine, the 35, then the sine. That is the sine of 35 degrees. Then we have multiplied by this 12 here. So that sine I multiplied with 12. Now it becomes 6.882, but we also need to divide it by 8. Divide by 8, which now becomes 0.8603. That is the sine of b, but you see, we need the angle of b, we don't need the sine of b. So that sine of b, when we round it off to 4 decimal places, it becomes 8604. But you see, we need to get the angle now, because we have the sine of this angle b. We just need to go back to the calculator and find the sine inverse of this sine here. So it will be sine inverse of 0.8604. So I'm going back to the calculator. I can just clear this one, and then I get 0.8604, 8604. Then I go to shift, this one here. Then I click, of course, the sine, so that I can get the sine inverse here. And the sine inverse is 59.36, which means, of course, this angle will be 59.5 if I round up to 1 decimal place. So now that angle becomes 59.5 degrees. So we have used the sine rule to find the angle, a missing angle, but we can also use it to find a missing length. Like in this case, find the length of C. You see, we have the length of A now, 8 centimeter. We have the length of B, which is 12 centimeter. And we have angle B, which is 59.5 degrees, the one we have found. And we also have angle A, which is 35 degrees. So we are only missing angle C and length of C, so that this triangle can be complete with the angles and the sides. One thing before we find this length of C, we need to understand that if we take the sum of the angles of this triangle here, that is A plus B plus C, they should total up to 180 degrees. So, since we know A is 35 degrees, and we also know B because we calculated it here and we got it as 59.5, then if we take 59.5, we add 35, then plus this angle here, they should be equal to 180 degrees. So, A plus B plus C, which are the angles, should be equal to 180 degrees. Then it means, if I take that 35 plus 59, then plus C should be equal to 180 degrees. So now it means, of course, to get just this angle here, C, I should take 180 minus 35 plus 59.5. And if you use a calculator to get this value, it will automatically be 85.5 degrees, meaning this angle here is just 85.5 degrees. So now you see we have all the angles. We have angle A, angle B, and angle C. And then we have to find the length of C. So since we are asked to find the length of C, and don't forget we had also calculated the length of B here. I think it was 12 centimeters. So we are only missing this side here. So I can just say, if I take C divided by the sine of C, which is this one C, divided by the sine of C is equivalent to A divided by the sine of A. Reason being, I don't need to use B sine of B because, of course, though we have the values, we can just reduce the formula to just specific section we want to find, and in this case we only need the length of C. So in this case I can just use this C divided by the sine of C equals to A divided by the sine of A. But you see, we are asked to find C. So the next thing would be then C divided by the sine of C, which is 85.5. Of course, we got it. The sine of the angle directly opposite to C, which is 85.5, is equivalent to A, but we know A is 8 centimeters divided by sine of A, but sine of A is of course the sine of 35 degrees. Then from there, you can just go ahead and say C is just equivalent to, and just cross multiply, and then it becomes 8 sine of 85.5 degrees divided by the sine of 35, of course, because I cross multiplied here and divided by the sine. So to get C, of course, I can just go direct to the calculator and I say the sine of 85.5, sine 85.5 divided by sine 35. So from there, if you go direct to the calculator, you will find the sine of 85.5 is just 0.9969. Then divided by the sine of 35, we had found it earlier, which was 0.57.36. Then from there, this is just the normal multiplication, which now becomes C is equals to 13.9. We can just try it in the calculator. We say 8 multiplied by 0.99, 0.996969, we get the answer, which is 7.9752. Then we divide by 0.5736, like that, and now it becomes 13.90, which when we round off to one decimal place, it is 13.9 centimeters. So then it means, of course, this side here will be 13.9 centimeter. So that's how we can use the sine rule to find missing sides and missing angles of a given triangle. That's it for now for this lesson. Let us meet in the next lesson where we are going to explore the cosine rule. Bye for now.